numerical session, we are going to take some questions based on the capacitors. Now the first question is given here, keeping the voltage of the charging source constant, what would be the percentage change in the energy stored in a parallel plate capacitor if the separation between the plates were to be decreased by 10%? That means separation to be decreased by 10%. And we all know that what is the formula of energy is half CV square. And I think all of you know C can also be written as epsilon naught A by D into V square. So keeping the charging source constant, that is voltage constant, epsilon naught A, all are 2 are constant. That means we can say that U is inversely proportional to D. Now distance is decreased by 10%. So when separation is decreased by what? Decreased by 10%, then do you know the energy is U dash. So we can say that U dash is what? Inversely proportional to D dash. So can we write U dash by U equal to what? In the same way, D by D dash. So it can be written as, because it is 100 by 90, because so we can write 100 by what? 90, or we can write U dash by U equal to what? 10 by 9. Remember? So got it? Decreased by 10%. Decreased by 10% means 1 minus 1 by 10. So it becomes 100 by 90. So this is this case. And finally, percentage change in what? Stored energy. So percentage change, you know how to find out percentage change. That is U dash minus U by U into 100. So you solve it, it becomes 10 minus 9 by what? 10 minus 9 by the value 9 into what? 100. So simply it becomes 100 by 9. That comes 11.11%. So this is the question, first important question. Simple relation between U and D is there. Rest of the things are constant. Distance is decreased by 10%. Certainly the energy stored is what? Increased by what? 11.11%. Okay. So this is the first question. Now come to the second question. Second question, you see the capacitors C1, C2 having plates area A, each are connected in series as given in the figure. Compare the capacitance of the combination with capacitance C3. Again having the plate area same here, but made up like this. So we have here 2 capacitors and we have to compare with this one. So simply how we are going to compare is, see here, this is the capacitance C1, this is the C2. Simply all of you know that C1 is K1 times of C0. So C0 we know that it is epsilon naught A by D. Similarly C2 can be written as K2 C0. You know, remember it will be this. So this can be written in this, and I think both are in what? Series. So you directly write what will be the combination of C, or these two will be C1 C2 upon C1 plus C2. I'm not going to write it directly. And if you put these values here, epsilon naught A by D will be common. In bracket we can write K1 K2 upon what? K1 plus K2. So this is the combination of these two capacitors. Now come to the capacitor C3. If you see C3 capacitor is actually, see here, series combination. It is series combination of the 2 capacitor, one of this and another of this. Even we can break it like this, same way we can break it like this, because it is of what? K1, it is of what? K2. So again say this is what we can consider these 2 capacitors as what? C1 dash and C2 dash. I think again C3 will be what? C1 dash C2 dash upon what? C1 dash plus C2 dash. Same thing will be here. So we put the values. We know that C1 dash is what? K1 epsilon naught A by D. C2 dash is what? K2 epsilon naught A by D. Same values. And when we calculate C3, it will be again the same. You put it here, epsilon naught A by D will come out, and it will be K1, K2 upon what? K1 plus K2. So what we observe is that the C3 is equal to what? C. So we can say that this C is what? C3. So actually both are working in the same way. C1, C2 in series, and you break it in like this: C1, C2, C1 dash, C2 dash in what? Again they are in series. So if you combine, you will get the answer of this. So this is question number 2. Very easy how to calculate the capacitance, and we know that C is K times of what? C naught. Now the question number 3rd. If you see question number 3rd is very important. The plate A, if you see the plate A of a parallel plate capacitor is connected to a spring. It's a spring of force constant K and can move with the plate B fixed. The arrangement is held between the two rigid supports. If a charge Q is placed on plate A and minus Q on B, by how much does the spring elongate? You have to find out the elongation of the spring. So can we find out the elongation of the spring? Yes, very easy. How? You all know that, say, suppose L is the elongation. Okay, and I think everyone knows F equal to minus KL if L is the elongation. And suppose that K, all of you know force constant, spring constant, we all know K is force constant. And suppose the distance is, say, X. See, X is the separation. X is the separation between the plates when it elongates between the plates. Okay, so if X is the separation between the plates, so what will happen? Do you know? C will be what? Epsilon naught A by X. So certainly this is C. Now what is energy? Energy is Q square by 2C. Can I write this what? Energy Q square by 2. In place of C, what I can write is reciprocal that X upon what? Epsilon naught what? A. Now all of you know how F is related with U. Now because F is a conservative force, can we write F minus du by dx? Yes, because F is a conservative force. So this relation we had gone through in 11th also with the relation. So minus d by dx, we are going to what? Take it Q naught Q square X by 2 epsilon naught A. And I think all of you know the differentiation. Q square by 2 epsilon naught will be the answer, minus. So this is the force, and then both the forces are this one and this one will be same. So what? F1 equal to F2. So minus KL will be minus Q square by 2 epsilon naught A. And then you solve it. What will happen? L will be Q square 2 epsilon naught Ka. So this is the answer. Got it or not? So very simple that there is a separation. The elongation is KL. Say X is the separation while it increases due to the force. C will be this. Then you know that you got U and you calculated energy. F is minus du by dx. Then both the forces will be same. And when you put it here, this answer will be Q square by 2 epsilon naught K by 2 Ka. Now question number 4. So that the force on each plate of a parallel plate capacitor has a magnitude equal to half QE, where Q is the charge on the capacitor, Q is the charge on the capacitor, and E is the magnitude of the electric field between the plates. Explain the origin of the factor 1 by 2. Now very simple solution is that say there are two plates like this. Now one is of positive charge and another is of what? Negative charge. So you know that there is a force between the plates. One plate acts a force on the another, and there is a force. So certainly there will be a work done. Say this is the plate, and there is a change. Do you know delta x? They attract each other. And sigma is what? Q by And all of you know that electric field is what? Sigma by epsilon naught. So sigma can also be written as epsilon naught into E. These things are already there. Now suppose we say that the separation between the plates is delta x change. This is the delta x increase or change. So what we can say is that work is equal to F delta x. Okay, so work done will be F delta x. Now this is the first equation. Now this work is the form of what? Energy. Energy of the capacitor. Now I think all of you know there is a word energy density. Half epsilon naught E square. This is energy density. Okay. And energy density is what? Energy per unit volume. You remember? It is energy per unit volume. That is the change in volume. So can we write U into change in volume due to this force? And then that energy, what is the change in volume, is what? Area into distance, and distance is what? Delta x. So this will be the energy. Are you getting it or not? Energy density. Remember, energy per unit volume, energy is upon change in volume, that is equal to U into change in, and this will be. So first and second will be equal. So what we can do is that first is equal to second. Okay, so we can write F delta x equal to UA delta x. So delta x cancels out, and F is equal to U. What is U? It is epsilon naught E square into A. So can we write half epsilon naught E into AE? We can write it in this form. Got it? And then F is what? Half what? In place of epsilon E, we can write sigma. So sigma what? Into A into what? E. And finally, F is what? Half sigma A, and sigma A is what? Q. So half QE. This is the answer. Are you getting it? That is half QE. So this is the answer, that force on each plate. And then there's a case that the electric field, it is written the origin of the factor. So factor of the origin is very simple. Say this is a plate, this is a positive charge plate, and inside the electric field is E, but the outside the electric field is 0. So what happens? That we take the average value of electric field, that is average value of what? E by 2, that contributes to the force. So remember, what is the origin of the factor of 1 by 2? So simply we get first half QE, and how we have got the work done is equal to energy. Energy we got from energy density, and both are equal, then it is half QE. Half is the factor which is due to the average value of the electric field. Question number 5th, and see what 5th says. The given graph shows the variation of Q versus V for two capacitors C1, C2. The two capacitors have same plate separation. That means the same plate area of C2 is doubled of C1. Which of the line graph corresponds C1 and C2? Now plate areas same. So all we know C is what? Epsilon naught A by D. D is same. Okay. So what we can say is C is directly proportional. If you see the figure, A has greater capacitance than B. Can you see it? Yes or no? What is capacitance? You know, Q by V. So you see the slope of this graph is greater than this graph. So A has greater. Now C is directly proportional to the plate area A. Remember? And C2 is double than C1. So C2 has double area than C1. So C2 is greater than what? C1. So hence what? A is what? C2, and B is what? C1. So very simple question. C is this, D is same, C is directly proportional to area. So C2 is greater than C1. So C2 will have more capacitance. And if you see the slope of the graph, which has more capacitance? A than B. So this is simple. Now come to the question number 6. Now question number 6, what it says? A parallel plate capacitor of capacitance C is charged to a potential V by battery. What is, without disconnecting the battery, the distance between the plate is tripled, that is thrice, and K is 10 introduced between the plates of the capacitor. And then you have to give the region how the following things are affected: capacitance of the capacitor, charge on the capacitor, and energy density. Three things you have to find out. You know that distance is tripled and K equal to 10. So one by one we can say, what is in air medium capacitance? Epsilon naught A by D. What is new medium? It will be K times of epsilon naught A by what? D dash. So what is the D dash here? You know that it has become what? 3D. So K is what? 10. So 10 by 3 is what? Epsilon naught A by D. What? So we can say is that C is 10 by 3 times of C naught. So first answer we get it here is this. Okay, got it? And then charge on the capacitor. Charge, can you find out charge? Yes. What is Q? CV. Okay. C is K times of C naught. So K times of what? So this one. So directly I am writing 10 by 3 of C naught. We have calculated. And this is V. So 10 by 3 of what? Q naught. So this will be the charge. And the energy density, I think all of you know, energy density, it was half epsilon naught E square. Now new energy density will be half epsilon naught what? Say earlier electric field is E, now it is E square, because now it is in dielectric medium. We put it here half, say epsilon naught, epsilon E square, so in the medium. So K times, you remember epsilon naught, and in place of E, what you can write is E naught by K. You remember it or not? So calculated, it becomes 10 by 9 of half epsilon naught E naught square. So it is 10 by 9 of U naught. Remember what is epsilon? It is K times of epsilon naught. So remember the new one is epsilon E square. And what is E? It is E naught by K. Already we have done these things. So this is the solution. Capacitance 10 by 3, charge 10 by 3. It is 10 by what? 9. So this is question number 6. Okay. And then come to the question number 7. 7 is this. If you see question number 7 is a network of 5 capacitor connected to 100 volt supply. Calculate the total charge and energy stored in the network. So we have 5 capacitor, 3, 3, 1, 1, and in mid here it is 2, and this is 100 volt. So first of all, we will arrange these capacitors. We have to arrange these capacitors, and arrangement will be done for this. You know, arrangement can be done in this way. These 3 are in what? Parallel. And then these two, and then these two are also in parallel, though they will be written as like this. And then this is parallel to 2. See the arrangement, how we are going to do. And this is 100 volt supply. So this is 100 volts. The arrangement will be changed. This is 3 microfarad, 3 microfarad. This is 1 microfarad. This is 2 microfarad. And this is 2. So we have to find out what total energy, total charge and energy stored. So these two are in what? Series. So C1, 2 we can write 3 plus 3 not series parallel. So 6. Okay. And these two are also in parallel. Say C3, C4. So C3, 4 can be written as C3 plus C4. That is 1 plus 2. That is what? 3 microfarad. And then both are in what? Series. So 1 upon C dash will be 1 upon 6 plus 1 upon 3. So I think you will get, if you solve it, 1 by 2. So C dash is what? 2 microfarad. So of this you get 2 microfarad. And then this 2 is parallel to this 2. So net capacitance will be 2 plus 2, 4 microfarad. So remember that this is 4 microfarad, and what will be the charge? Q is what? CB. So 4 into 100, this is 400 microcoulomb, because 100 is the potential difference. So it will be what? 400 microcoulomb. Got it? How you get? 336, 213 and then this will be the solution 2, and then this 2 is in parallel with this 2. So you get 400 micro coulomb is the answer. Now energy is half Cv square, and you put it here, you solve it. Half C is 400 into 10 to the power minus 6, and potential is 100 square. So you calculate it, it becomes 0.02 joule. So this is the energy for question number 7. Simple. 3, 3, 1 over 2, and you got it like this. Okay, so now question number 8. Find the ratio of the potential differences that must be applied across the parallel and the series combination of two capacitors C1 and C2 ratio 1 ratio 2, so that energy stored in the two cases becomes same. Again repeating, find the ratio of potential difference that must be applied across parallel and series combination, same potential difference, so that their ratio is given capacitor and energy stored in the cases becomes the same. So we are going to find out this condition, that how this condition is going to apply. We will take two capacitors, say two capacitors are taken, like one is the case when they are in parallel, and the other is the case when they are in what? Series with the battery, like this. Are you getting it? One C1 C2 and C1 C2. And I think that the case is very simple, because C1 by C2 is already given 1 by 2, and as what the energy stored is same, so that the ratio becomes the same. So we will take the energy stored. Energy in series is equal to energy in what? Parallel. So can I write 1 CS V S square equal to 1 CP VP square, half CV square. So I have written in this form. And then what we can see is that we can do the ratio of it. Can I write Vp square by Vs square? From here it will be just the ratio of out. So Cs by Cp will be the ratio of this. So Vp square by Vs square is this. So can we write this is what? How we are going to calculate what is Cs? Cs is the what? The series. So can we write the Cs form? Yes. C1 C2 upon C1 plus C2. What is in parallel? Parallel is C1 plus what? C2. Got it? Series C1 C2 upon C1 plus. So this can be written in this form. Can I write C1 C2 C1 plus C2 whole square? Because it will come down. And then I will divide C2. I will take common here. So C1 by C2 upon, can I write C1 by C2 plus 1 whole square. This is a mathematical. What I have done, I have taken C2 square outside. So this can be, because, and then this will be, C2 will cut it. So it can be written in this form. And then finally you put the value. What is C1 by C2? Half. And what is C1 by C2? Half plus 1 whole square. And solve it. You will get it 2 by 9. So Bp square by Vs square is 2 by 9. Can I write what is Bp by Vs? Yes, it is square root 2 by 3. So this is the answer. Again repeating, capacitor ratio is given, energy is same. You have calculated the relation. Cs is this, Cp is this. Then you got it. Then you took C2 square outside, so that it can come in the form of this. Then put the values, and finally this will be the answer for this. So this is question number 8 and what 9 and question number 7 and 8. Now 9 is here. Now 9 you can see a capacitor in near medium has a capacitance C0 in near medium. If the 25% of the width between capacitor plate is filled by dielectric medium, epsilon R equal to 4, then find the percentage increase in 25% of the width. That means T is the thickness and it is 25% of D. The plate separation, you remember, it is D, and for a dielectric it is what? T. So it is given like this. So T is what? D by 4. What was the formula for the capacitance? Epsilon naught A. Remember it, D minus T, 1 minus 1 by K. It was for what? It was for dielectric. K is here 4. So put it here, epsilon naught A, D minus T. In place of T, it will be D by 4, and 1 minus K is 1 by 4. So calculate it, epsilon naught A, D minus D by 4. What is 1 minus 1 by 4? It is 3 by 4. So calculating it, it will be d minus 3d by what? 16. So it becomes 16 epsilon naught A, and 16 minus 3, it is what? 13d. Again repeating, it is 3 by 4, 3d by 16, and this will be 16d minus 3d, it will be 13d, 16 times of this. So can we say the percentage increase? C is 16 by 13 of C naught. Got it or not? Percentage increase you can find out. It will be C minus C naught by C naught into 100. So can I write 16 minus 13 by 13 into 100? So it will be 3 by 13 into 100. So the percentage increase is 300 by 13%. This is the increase in percentage. So 300 by 13%. So you can solve it. So this is the answer. And then last question is question number 10. If C1 and C2 and C3 are given and the insulated plates of C1 be at potential of 90 volt, this one at 90 volt, and one plate of C3 being earthen. If it is earthen, then it is 0 volt. So what is the potential difference between the plates of C2 as three capacitors are connected in what? Series. Now we all know that these three are, this end is at 90 volt, this is earthen, it is written here. So C1, C2, C3. So what is the series combination? I think all of you know. You write like this, and I think it is given, it is of 20 microfarad, it is of 30 microfarad, it is of 15 microfarad. You can write here 1 by 20 plus 1 by 30 plus 1 by 15. Solve it out, it comes 3 by 20. So net capacitance will be 20 by 3 microfarad. So this is the net capacitance. And then find the charge. Charge is what? Q equal to CB. So you can find out the 20 by 3. What is the potential difference? 90 minus 0. So it is the potential difference. So calculate it. So it will be 20 by 3 to 90. So this will be 30. And do you know micro is 10 to the power minus 6. So 600 microcoulomb is the charge. And then can you find out, because in series what is same? Q is same. We have this concept. So Q is same. So what will be the potential at what? You have to calculate at plate C1, you have to C3, and you have to calculate at what? Say C2. So C2 you have to calculate. It will be what? V2. Q by what? C2. So Q is 600 into 10 to the power minus 6. And what is C2 is 30. So 30 micro is this. So calculate it. I think the answer is 20 volt. So this is the answer for this question. All three were in series. One was earthen and other was 90. You calculated the net C, then net charge, and then charge is same in series. So you can get the potential difference. So this way we can finish all these numericals. And thank you, and watch all the videos to clear your concepts.